Welcome to Podkey Slopcast, where AI economics gets unpacked without the hype. A lot of AI debate keeps collapsing into one question: will the machines take the jobs? But the harder question is what kind of work, value, and power actually survive when automation gets cheap and weirdly uneven. And once you ask it that way, the clean stories start falling apart. Start with the part of the economy that may refuse to behave like software. The relational sector means goods and services, where people care that a human is involved, not just that the outcome gets delivered. Think ballerinas, baristas, therapists, teachers, maybe certain kinds of care work. The important claim here is not that automation fails, it is that full physical automation still might not eliminate scarcity if customers place value on human presence itself. That would matter a lot for labor demand because it creates pockets where automation can improve production while human labor keeps pricing power. But the honest answer is, we do not know how big that sector is. You cannot settle it with vibes or a clever Twitter thread. The missing evidence is willingness to pay data and targeted conjoint studies that test whether consumers really pay for human involvement once a machine substitute is good and cheap. That uncertainty bleeds into the bigger labor versus capital argument. Historically, labor's share of income has sat around 60%, and some of the decline people point to may partly reflect accounting choices rather than a pure transfer from workers to owners. If that is right, the economy may be more complementary than the simple robots replace humans story suggests. Still, there is a real counterpressure now. Compute is not following the old intuition that capital just gets relentlessly cheaper in a way everyone can easily access. Frontier GPUs, memory, and training capacity are scarce and expensive. That can raise the marginal product of capital and strengthen the hand of whoever controls it. A lot depends on the unit of analysis. Jobs are bundles of tasks, and the O-ring idea says performance can hinge on the weakest link. If AI automates 80% of a job, that does not automatically mean 80% of workers disappear. Sometimes it means the human gets pushed into the remaining bottleneck task and becomes more productive because the surrounding work is faster. In that case, partial automation raises output and can even preserve employment. But that only works if the remaining human task still fits the workflow. If the last human step is too slow, too inconsistent, or too costly relative to end-to-end machine performance, firms may skip partial automation entirely or hold the whole process back until full substitution is possible. So outcomes will vary a lot by occupation and by firm tolerance for mixed systems. The same caution applies to demand. People love invoking Jevons paradox, where efficiency makes something cheaper and demand explodes. That happened with coal in certain historical settings, but it is not a universal law. Many AI outputs may hit saturation. If software gets 10 times cheaper, people do not necessarily want 10 times more mediocre summaries, ad copy, or generated images. Some use cases scale hard with lower cost. Others flatten out because marginal utility falls fast, so cheaper AI does not by itself prove labor will be displaced by an endless wave of new demand. A surprising amount of this debate is running on stale or missing data. We do not have high-frequency, task-level tracking for what gets automated, what new work appears, or how consumers value human alternatives. ONET is useful, but it was not built for an economy where task boundaries can shift quarter to quarter. If people are calling for a Manhattan Project for data, that sounds dramatic, but the basic point is solid. Without better measurement, forecasts about AI and jobs are often arguments over assumptions disguised as evidence. That is also why prediction markets are attractive here. Economists disagree wildly on AI labor effects, and aggregating those bets could outperform any single expert. Markets would not give certainty, but they would force forecasters to price their confidence instead of just publishing a hot take. On the business side, one of the clearest shifts is that AI firms increasingly operate like token efficiency businesses. The goal is not merely to use the smartest model, it is to deliver the outcome with as few tokens, as little latency, and as much reuse as possible. That changes what counts as competitive advantage. Better context management, routing smaller models to easy tasks, continual learning, harness design, and reuse of prior reasoning can all save real money. In other words, architecture matters, not just model leaderboard scores. This also helps explain the growing talk of a token shortage. If demand for inference and training is exploding faster than compute supply, then labs stop behaving like growth-at-any-cost consumer apps and start behaving like capacity allocators. Subsidized plans get squeezed, API pricing matters more, and high-end compute becomes strategic. The supply side supports some of that story. GPU rents are rising, memory has gotten more expensive, and suppliers like SK Hynix are talking about major capacity expansion across the decade. That does not prove a permanent shortage, but it does undermine the lazy assumption that compute will instantly become abundant enough to erase all bottlenecks. Benchmarking is adjusting too. A model that scores slightly higher but burns far more tokens may be worse commercially. Per token price alone misses the point if the model overthinks and generates huge reasoning traces. That is why average tokens per task is becoming a more meaningful metric. Hybrid routing is one practical answer. Send most requests to cheap models, escalate only when needed, and sometimes split work between local and cloud inference. Reported savings in the 20 to 25% range at equal performance are believable because the logic is simple. Do not spend frontier model money on commodity tasks. That matters for privacy too. If part of the task can run locally, firms can reduce token spend and exposure without asking users to micromanage model choice. At the product layer, companies are trying to hide complexity behind new primitives: annotations, role-specific plugins, codex-style site generation, frontier-tuned enterprise models, partner ecosystems. The promise is that non-developers can get usable automation without becoming prompt engineers. Some of that is real progress, but product expansion also creates new attack surface and dependency. Anthropic widening partner exposure, Microsoft pushing custom frontier tuning, and similar moves all make adoption easier while concentrating more operational power inside a few model ecosystems. And then there is the human side. KPMG's large workplace sample suggests top users do not treat AI like a vending machine. They frame the problem, iterate, critique, and guide the model as a reasoning partner. If that behavior is teachable, then a lot of productivity gain may come from organizational training rather than purely from model improvements. One fast-moving externality is web traffic. If bots are now 57.5% of traffic, that is a major shift in the economics of the internet. Ad models, analytics, security, and content distribution all get noisier when the audience is increasingly machines talking to machines. Policy is not settled either. Recent US trends lean toward voluntary safety testing, shorter review windows, and an explicit rejection of mandatory licensing or pre-clearance. Supporters see that as avoiding bureaucratic choke points. Critics see opacity, vague thresholds, and a system that can still centralize power while pretending to be light touch. The trade-off is real. More openness can reduce concentration and widen access, but it can also increase misuse and lower safety margins. More control can slow dangerous deployment, but it can also entrench incumbent labs and turn regulation into a moat. That leads to the last question. If AI creates enormous wealth, who actually owns it? Cash transfer ideas like UBI or a negative income tax are straightforward in concept but politically exposed. If people depend on transfers, those transfers become bargaining chips. Capital-based ideas like universal basic capital sound appealing because they target ownership, not just redistribution after the fact, but they run into hard implementation questions about what exactly citizens own, how private AI gains are indexed, and how public vehicles can capture returns when so much value sits in a small number of private firms. Traditional index funds may simply miss a lot of concentrated AI upside. That suggests sovereign wealth funds, targeted AI indices, or direct stakes may matter more than passive exposure if the goal is broad participation in gains. And underneath all of this is a quieter problem. Our macro statistics were not designed for a world of embedded AI services, autonomous production, or stranger forms of machine-created value. Even before the science fiction edge cases, GDP and national income accounting may be measuring the next economy with the wrong ruler. The through line here is not that AI will obviously enrich everyone or obviously wipe everyone out. It is that the answer depends on bottlenecks, measurement, ownership, and demand in ways the loudest narratives usually skip. That is it for Podkey Slopcast. This episode was generated by Podkey. Create your own at podkey.fm.